Hi students, I am Farida and this is my second lecture on wave optics. Students, in this introductory lecture, we revise all the properties of light and you have now have the basic idea of what is light. In this second lecture, we are going to discuss two things, that is nature of light and light as wave. Now, before that, remember, many researchers through the ages have taken up the challenges and finding out what is light. Optics is known as the oldest discipline along with mechanics. The progress of study of light has been made by the great scholars from different fields, and we can take their name as Aristotle, Newton, Huygen, Maxwell, Young's, Einstein, etc. So now here in this chapter or in this lecture, we are going to study, as I told just now, the nature of light. So now just we'll go ahead and we'll see what are the different natures of light. And we know, just now I took the names of those scientists, and in that way their different theories are there, and we will see one by one what are those theories, and according to their theories, what is the nature of light. So first comes the corpuscular theory. Okay, so here the first name comes, that is Descartes. According to Descartes, the light is in the form of particle. So he studied the formation of light, formation of shadow, and image by mirror, lens, and he think that this all is possible due to the rectilinear propagation of light. And he suggested that the light is in the form of particles. After that, Newton studied this phenomena and suggested his theory known as corpuscular theory, Newton's corpuscular theory. And what he suggested in his theory, Newton suggested that light is consist of very tiny particles, and these particles are known as corpuscles. Now these corpuscles are very hard in nature, elastic and massless. Now when these particles are propagating from the source, now you can see in the image, these are propagating from the source, they follow the straight line path. Means rectilinear propagation takes place over there of those particles. So light is in the form of particles, and these particles follow the straight line path. Now these are with high velocity. These particles are propagating with high velocity without any external force. In the absence of external force, they are propagating from the source. And when we get the sensation of light, when these particles enters to our eyes, we get the sensation of light. Okay, you can see here when they insert into our eyes and fall on the retina of the eye, then we get the sensation of light. Now in the second diagram, you can see different sizes of these small particles, means corpuscles are there. And these small sizes, different sizes, gives you the different colors. Means different colors are due to different sizes of the particle, according to Newton's corpuscular theory. So theory is very simple. What is suggested, light is in the form of particle, and these particles, tiny particles, are known as corpuscles, and these are rigid in nature, elastic, massless. And so when they emit from or propagate from the source of light, they follow the straight line path without any external field, they propagate with high velocity, and we get the sensation of light when it enters to our eyes, and different colors of light are due to the different sizes. Okay, got it? So theory is very simple. Now this theory can explain the rectilinear propagation of light. Now see here, the next thing what it can be explained, can it could explain the reflection of light. So according to the theory, when these corpuscles are falling on the or incident on the reflecting surface, they bounce back into the same medium, and that's why there is a reflection process. And in this way he could explain the phenomena of reflection, and Newton could explain with the help of his corpuscular theory. Now what about the refraction process? He could explain with the help of his theory the refraction process. Now according to him, when the particles are coming, these tiny particles, means corpuscles, are coming and entering to the another medium, these corpuscles interact with the particles of the medium, and there is a force of attraction between them, and because of this force of attraction between these corpuscles and the particle of the medium, they changes its path. Okay, and this change of path is nothing but refraction. So he could explain the refraction process. Now he suggested that when these particles, when the corpuscles are coming from denser medium, rarer medium to denser medium, the denser medium exerts a larger attractive force on the corpuscles, and that's why they accelerate along the norm, and so there is a high velocity of those particles into the denser medium. But after so many experiments, there is experimental conclusion or observation that the velocity of light in the rarer medium is high, and this theory contradicts that experimental observation. Okay, so according to Newton, the velocity of the velocity of the light in the denser medium is high, which is contradict to the experimental observation. That you have to remember. Okay, so we'll go next and we'll see what are the merits of this theory. So there are merits. Just in the previous slide we saw this theory, corpuscular theory, can explain reflection, refraction and rectilinear propagation. So the theory could explain reflection, refraction process and rectilinear propagation. These are the merits of this theory. Now what are the drawbacks or demerits of the theory? Yes, there are some drawbacks also. And what are those? Some phenomena like reflection and refraction, there are interference, diffraction, polarization, which are based on the wave theory, and these phenomena could not be explained by this theory, corpuscular theory, and this becomes a drawback of this theory. So he could not explain interference, diffraction or polarization with the help of the corpuscular theory. Next thing, it could not explain partial reflection and partial refraction at the surface of the transparent medium. To understand more in detail, we will see here. Now suppose like I want you to know this. Suppose what is a rectilinear propagation or a partial reflection and refraction refraction that I wanted to show you. And now suppose if the light is coming and incident on the surface of glass. Suppose I am taking here glass, okay, this is the normal drawn and this is the plane reflecting surface and or edge of the surface of the glass, we can say. So now suppose this is the incident ray which is coming and incident on at this point. So what will happen? Now here the some light will reflect back into the same medium and some will go here, transmit here into the glass, isn't it? So whenever we incident a light on a glass surface, then some will transmit into the second medium and some will reflect back. So this simultaneous reflection and refraction takes place over there. And this simultaneous reflection and refraction or partial reflection and refraction could not be explained by the by this scientist or Newton. So he could not explain the reflection and refraction. Okay, this theory predicted that the speed of light in the denser medium is more, and then then the speed of light in the rarer medium, that is experimentally proved wrong. This is another drawback of this theory. And if suppose if he is considering the light is in the form of particles, okay, so if any particle is suppose with a diagram I wanted to explain this thing again. So suppose I am taking here the source of light and the particles are moving from it. So what will happen to that? I wanted to show you. Here suppose this is the source of light I am taking and it is emitting particles from it. What will happen? A continuous emission of particles is happening over there, and this is the diagram where from the source the particles are moving. So these are the particles, and what will happen to this after some time? It will decrease, isn't it? So it will decrease because all the particles are coming out from it, isn't it? So particles are moving out. What will happen afterward? After some time it will go down and vanish, isn't it? But it is not happening in this case. So it is not too experimental, it is not happening, it doesn't happen. So we will not believe in that light is in the form of particle, isn't it? So in this way some drawbacks are there of this Newton's corpuscular theory, and that's why this later on this theory is discarded. Got it? So we'll go ahead and we'll see what is the next theory, and we will learn about it, and that is the wave nature of light. We saw the particle nature, and this will be the wave nature of light. Now what is there? What is mean by wave nature of light? Now here Huygen suggested this wave nature. Okay, so according to Huygens, light is in the form of wave, but he suggested that light is in the form of longitudinal wave. Okay, now if the longitudinal waves are there, so the material medium is required. Longitudinal wave means what? The waves which the vibration of the particles are in the direction of propagation of wave, isn't it? Those are called longitudinal wave. And if we are considering longitudinal wave, then the medium is required, isn't it, for its propagation. So now I wanted to show you that with the help of one experiment we can say that the light means the longitudinal waves required material medium, okay, for its propagation. So now see here, I'll show you. Suppose a small bell is taken, which is electric bell we are taking, and it is vibrating. So we can see its vibration here, and we can hear its sound also. Suppose this is kept here on the table. Now one glass jar is kept on it, okay. So even then air is the medium inside, and we can see it's vibrating, and we can hear the sound of that ringing bell, okay. So now what we will do, we will gradually take the air out from this jar, okay. And what we are doing by taking the air outside, we are creating the vacuum. As we decrease the air inside here, and goes on increasing the vacuum here, then we can see or observe that the sound is decreasing. And as soon as we created the vacuum here, taking all the air outside, then we cannot hear the sound, even though we can see the vibration of the ringing bell. It means that when the vacuum is created here, then we cannot hear the sound, okay. We cannot hear the sound. So again what we will do, again we insert the air. As soon as the air will insert over there, then we can see here, again we can hear the sound of the ringing bell. It means that from this small experiment, it is clear that the sound waves require the material medium for its propagation, okay. So sound waves are the type of longitudinal waves, isn't it? We can show in this way, or we can show by compression and rarefaction. With the help of this, we can show these type of waves. So the sound waves need the medium for its propagation, and so the longitudinal wave. So as he suggested that, Huygen suggested that light is in the form of longitudinal wave, he suggested that there is a material medium for its propagation, and that material medium, homogeneous medium with uniform velocity, they will travel in it. And this material medium which he has suggested, he had given the name to it as luminiferous ether. So according to him, the luminiferous ether, the medium, is present everywhere in the space, and that's why these longitudinal type of waves of light are propagating into the medium, according to him. And now the different colors of light, these are because of the different wavelengths of light, and whenever whenever they enters to our eyes, we get the sensation of light. So this is the wave nature of light, and this is the Huygens theory of light, okay. So what he suggested, the light is in the form of wave, and he suggested that those waves are of longitudinal type, and so he considered that there is a material medium present, and that material medium is known as luminiferous ether, and it is present everywhere in the space, so that the waves can propagate in. Okay, and we get the sensation of light because of the entrance of light into the eyes, and the different colors are possible due to the different wavelengths of light. Now there are some merits of this theory also. What are those merits? So what are the merits? It could explain reflection, it could explain diffraction, even interference and diffraction could explain by this theory, and he predicted that speed of light in denser medium is less than the rarer medium, and so these are called the merits of this theory. Okay, so what are the demerits of this theory? Now, experimentally, it is proved that the light wave are transverse type of waves. Those are not the longitudinal type, and transverse type of waves are there. So, crest and troughs are there. Okay. So, he suggested that light is in the form of longitudinal wave. So, this becomes the drawback of it. Now he could not explain the rectilinear propagation of light. As he suggested the light is in the form of wave, so he could not explain the rectilinear propagation of light. Okay. Now this third drawback is it could not explain, this theory could not explain the phenomena of polarization, Compton effect and photoelectric effect. Now these phenomena are based on the different nature of the light, and so he could not explain these phenomena, that polarization, Compton effect and photoelectric effect. Now as he suggested that hypothetical medium ether is present, and that is actually experimentally proved wrong. No such type of ether is present anywhere. Okay, so these are called some drawbacks of Huygen's theory. Now we'll go ahead and we'll see, is this theory get accepted? Yes, it is accepted because Huygens made some correction in his theory using or taking help of Maxwell's electromagnetic theory. So just we'll go ahead and we'll see what is electromagnetic theory of Maxwell. So Maxwell's electromagnetic theory. Now he postulated existence of electromagnetic wave. So according to him, electromagnetic waves are present. So what are those? He established relationship between the magnetism and electricity. So according to him, the electromagnetic wave is a combination of electric and magnetic waves. Okay, and the velocity of electromagnetic wave was experimentally found to be equal to that of light. So they are of highest speed and velocity, same as that of light. Hence, light wave were assumed to be electromagnetic waves, and that's why they are assumed to be electromagnetic waves. And it was also observed that no medium was necessary for the propagation of the electromagnetic waves. So as we saw, Huygens considered the longitudinal type of wave light as, and so he considered the luminiferous ether is the hypothetical medium present, and in that medium only, due to that medium only, the light can propagate, isn't it? So from his Maxwell's electromagnetic theory, it was concluded that light is not required any type of medium for its propagation, and it was also observed that no medium was necessary for the propagation of electromagnetic waves. Okay, they can travel through vacuum, they can travel from any type of medium. Now, if we are considering now light as waves, so which type of waves we are considering it? Light is an electromagnetic wave. Now we are considering light is an electromagnetic wave. Now, if we are considering light as an electromagnetic wave, so here you can see light is this is the direction of propagation of light. We can see now here this is the direction of propagation of light, and we see the combination of light here. This is suppose the electric wave in blue color. I am showing this electric vector we are showing, and red one is the magnetic vector. So if you will see it carefully, then we can see here now. I wanted to show you on this with the help of diagram again. So now suppose light is coming and propagating in this direction. Okay, suppose, and one vector we are showing in along y axis. Suppose this is the direction of propagation of wave. Okay, this wave is coming like this, so here in this direction it is coming. Suppose this is the x direction, and this is we can say this is the y axis. Okay, and this one is the z axis. All three axes are perpendicular to each other, that we know. So now this is suppose electric wave we can say, or electric vector. Okay, and the vibration is in y axis. So this is the direction of vibration of the wave. This is the propagation, direction of propagation. Now if you will see, I wanted to take different color. So here now suppose I am taking the another wave which is now vibrating in this direction, which is perpendicular to this direction. Then you will see clearly this is the horizontal plane, isn't it? This is the vector we can show here in this direction. So this is the magnetic vector, this is the electric vector, and this is the direction of propagation of wave. This is the direction. So in this way we can say that the magnetic vector, electric vector, and the direction of propagation of wave are perpendicular to each other. Okay, so we are considering here the electromagnetic wave, and I think I could not see the board which I shown just now, so I'll show again this thing so that you will get a clear idea about this. So, can you see this? Okay, now see here I am showing you. Suppose I am taking this is the direction of propagation of light. So this is suppose x-axis I am drawing, and this will be the y-axis. Now the light is propagating in this way. Now suppose along y-axis the vibrations are there of this wave, and the direction of propagation of light in this way. Okay, here it is coming like this. Okay, So wave will come like this and propagating in along x-axis. Now the electromagnetic waves is nothing but the combination of electric and magnetic wave. Okay, so now this is the y-axis, this is the x-axis. Now the remaining is the z-axis I am drawing here. So now this is the another wave along the z-axis I am drawing, and you can see this wave is perpendicular to the direction of the y-axis. So here this is the vibration of the electric vector. Suppose this is the electric vector and this is suppose the magnetic vector. So these two are perpendicular to each other, isn't it? So now this is the magnetic vector we are getting, this is the electric vector we are getting, electric, magnetic, and this is the direction of propagation of light. So this is direction of propagation of light. Okay, so all these three, if you will see, all these three are perpendicular to each other. So electromagnetic wave, if you are considering, it is a combination of electric vector and magnetic vector. These are perpendicular to each other, and again they are perpendicular to the direction of the propagation of the wave. That is important. So light is an electromagnetic wave. Now the next thing we will see, what is electromagnetic wave that we got. These are transverse in nature. Now you can see easily here the crest and trough are formed, and the vibration of the wave is perpendicular to the propagation of light. Then it consists of tiny oscillating electric and magnetic field which are perpendicular to each other, and the direction of propagation of the wave that I just now explained to you. These waves do not require any material medium for its propagation and can even travel into the vacuum. As we suggested, electromagnetic wave do not need any material medium for its propagation, so they can propagate in the vacuum also. Now if we consider the speed of light in the material medium, that is v, and a refractive index of the medium is n, then we give the relation of this refractive index with the help of this formula, and here we can say the refractive index is depends upon the speed of the light in the vacuum to the speed of the light to the into the medium. And you have to remember that the refractive index of the vacuum is always 1. Now I think it is important to know about the Max Planck's quantum theory. So according to quantum theory, I say light is in the form of quanta or packet of energy or bundles of energy. When the light is propagating, it is not in the form of particles, it is not in the form of wave, but according to the Max Planck's quantum theory, the light is in the form of packets or the bundles of energy, and these bundles or these packets are known as quanta or photons. Now each quantum of light called photon. And what is photon? Photon is the particle having no mass and no charge, and photons are carrier of electromagnetic radiations. Okay, and it is having high frequency, and if you will see or calculate its energy, that is equals to h into nu, where h is the Planck's constant and nu is the frequency of that radiation. Okay, and so it is all about the different theories of light, and so Till that time, thank you. Stay home and read a book of physics, probably. Thank you very much. Have a